Hey everyone, welcome to my session at the DataStack Summit. I am excited to be here today talking about the data warehouse in the data lake. Before I go ahead and get started, just a quick introduction. My name is Ali Leclerc. I'm the head of community at Ahana, the Presto company, and I'm also the chairperson of the Presto Foundation Community Outreach Team. So with that, let's jump into the agenda. What are we going to talk about today? First, I'm going to do a quick intro on data warehouses and data lakes. Hopefully it's things you already know, but it's always good to do a refresher. Going to talk about the data lakehouse, what that is, and why we talk a lot about Presto for the data lakehouse. I'll go through some real world use cases, and then if there's Q&A, we can go through that. So without further ado, let's get started here. So let's talk about the traditional data warehouse. Obviously, it was a relational database, typically with a columnar structure. You had those in-database analytics for performance, which focused really on, again, structured data. And that meant that data has to be modeled or had to be modeled. And the data modeling was somewhat of an endless task. You had to ETL that data, you have to extract that data from all of your data sources and then transform it. And then finally, you have to load it into the data warehouse. And then it was primarily accessed through SQL. So data warehouses were made up of a few data sources, a few different outputs, but for the most part, if we look at the challenges here, they were and they still are fairly expensive. They're slow, they can be difficult to manage, and they can be expensive to maintain. And they provide access to somewhat of a limited amount of data. And so, yeah, there's a lot of challenges, of course, a lot of benefits, but a lot of challenges as well. So if we move to the data lake and take a look at just the data lake in and of itself, we all remember Hadoop. Hadoop was going to replace the data warehouse. Everyone was reading that the warehouse was dead and Hadoop was taking over the world. And so just a quick primer on Hadoop. It's a file system data storage that was really inexpensive to use. Loading data into the data lake was really cheap. You could store all types of data, structured, semi-structured, unstructured. It was all about ingesting data, loading it, and creating the structure once you had all the data in there. And you could keep all your data in there. So one of the big things Hadoop helped with was the separation of storage and compute. So the first time you really separated out the two layers where you had storage with HDFS, and then compute went through many iterations and generations, even in the Hadoop timeframe. It started with Hadoop, MapReduce, and then it moved to Hive. But that's really where you saw the separation of compute and storage start gaining a lot of steam and traction. Primary use cases were for discovery, text analytics, data science, mostly Notebook and Python and other languages, because the primary way to access, because those were the primary ways to access, although there was some SQL access as well. So while the data lake was less expensive, there was limited performance, especially when it came to complex analytics as compared to the data warehouse. So there was limited SQL access. In general, the data lake was kind of hard to govern. So those were kind of the two big challenges with that. Hadoop didn't really have enterprise capabilities at first either. And so I think one of the biggest challenges with Hadoop was that it was really hard to use. It was never really simplified. And while technology is great to build and it solved a lot of problems, if it's complicated and it takes too long to get value from, then it doesn't really serve its purpose. And so over time, people struggled with it. So let's talk about the drivers. What were the drivers behind the modernization of the data warehouse and the data lake? So I'll start by saying that cloud is one of the biggest drivers of all this. And I'll cover more details later on that. But what we've seen since the inception of the data warehouse and the rise in the data lake with the advent of Hadoop, there's been a really fast modernization of these platforms that are driven by three things. So first, as you can see on the slide, is digital transformation. Everything's moved to digital now, right? It's massive upticks of things like mobile tech, more interactive web and mobile apps. Mobile apps and web apps that are way more engaging, and there's tons of new data and data types. So along with that is an uptick in engagement with your employees, with your partners, with your customers, et cetera. Second is everything is moving closer to real time, which has created a need to respond really quickly to business events of any kind. And then third, as you can see here, is really being on the cusp of seeing, we're really being on the cusp of seeing something that's, seeing everything being automated. In the world of robotics, for example, there are these like massive plants where everything's being automated. In order to automate everything, that requires incredible intelligence that can be delivered to machines and sensors and all kinds of devices in the IoT space in order to automate everything. So three kind of key drivers behind the modernization of data warehouse and data lake. So these trends have really pushed us to the modernization of both the data warehouse and the data lake. And if we look at this slide, modernization is happening in both places in all areas. So the most modern of both is cloud first, which I alluded to earlier. And there are increasingly more companies who are moving to the cloud. And there are increasingly more companies that are born in the cloud. And I call these digital native businesses. Their entire infrastructure is in the cloud. It could be one cloud, it could be multiple clouds. And then going a step deeper on the cloud first, we're seeing a lot of containerization. So today, Kubernetes is super popular, very stable. A lot of companies are leveraging containers like Kubernetes to run their business. Even at my company, at Ahana today, we were born in the cloud. We built Ahana as a cloud first, and we built completely on Kubernetes and containerization to take advantage of the flexibility of the cloud and the availability of the cloud and the scalability. Next is there's a move to in-memory capabilities. On the data warehouse side, that means bringing in more complex data types than ever before. And the modern data lake is now bringing in, we're seeing more columnar data types. I talked earlier about the separation of compute and storage, and that's a huge trend we're seeing a lot more of now. I won't go through every single one of these bullets in detail, but it kind of gives you a good sense of where we are today and when it comes to looking at the data warehouse and the data lake. I do want to touch on the open formats as well within the data lake. So formats like Apache ORC, Apache Parquet, they can be consumed by many different engines. So you're not locked into one specific technology, and you can move from one engine to another. So for example, Spark supports it, or Presto supports it. TensorFlow just added support for it. And so with the data lake, you can leverage open formats, which are highly performant and have multiple layers of processing on top of it. So I wanted to call that out as a pretty big benefit of the data lake. And of course, data warehouses are doing a lot to expand and extend themselves into the data lake. But what happens is when you have a critical path for any product, it's built for a specific type of data. So with data warehouses, it's proprietary formats. Cloud formats like S3 might be an extension. But that's kind of how they're built. And then with data lakes, they're built for open formats and not for those proprietary formats. So these are some of the considerations to think about as you're looking between the data warehouse and the data lake and how you want it to be. So let's move on to the next slide here. So combining the both of best worlds, what does that really mean? We've talked a lot about data warehouse and the data lake, the differences between the two. But now I want to talk about what's going on today in the market. And it's this idea of kind of merging the data warehouse and the data lake. You might have heard the term of data lakehouse. We're at a point where these two things are converging. And I'll talk in more detail on the data lakehouse later on. But first, let's talk about why we're seeing this trend and specifically how a distributed engine like Presto is helping drive this. So which one do you want to bet on for the future? Where is your primary path that you're going to optimize for? And the reason that this is important is because it's going to tell you where your data is going to live. Is, for example, 80% of your data in the warehouse, or is it in the data lake? And that's an important decision, and it's driven by the business requirements you have. So what we're seeing is if you have dashboards, if you have reports, and you need really high performance access to those things, the data warehouse is a good fit. But there's an emerging trend of a different kind of analysis, and consolidating that in a lake, it gives you the ability to run these kinds of future-proof technologies on a lake. And there's so much innovation happening on the lake today, so that becomes a fundamental decision. The next path, and even if you choose one way or the other, the good part is that you do have a layer on top that can abstract that and give you access to both, and that's with SQL. So you can query across multiple data sources. Just quickly out of HANA, we see that most folks are leveraging the data lake, and then they query maybe one or two other data sources. So let's take a look at this list here. First is SQL access, which is important. Most companies have data teams that know SQL, that can run SQL queries, and that can use SQL to access data. So leveraging those resources to get better insights into your data lake and your data warehouse, that's bringing the best of both here. Then you have unified analytics, which means that you can support more of your business use cases with a distributed query engine. And distributed query engines means that you can leverage your existing platforms and your data sources with limitless scale for all data types, which is incredibly powerful. So that's kind of what we see here on this idea of merging the data warehouse and the data lake with a distributed query engine. Oh, I'm sorry, my slide's a little funky here, but anyways, let's talk about the Open Data Lakehouse. So this convergence of the data warehouse and the data lake, what does it actually look like? If we look at the past few decades, if you wanted to do SQL processing at a pretty large scale, you'd probably use the enterprise data warehouse, which makes sense. It was purpose-built for SQL because it's widely adopted. It's a great language for interacting with the abstractions you have, which are things like tables and doing things like reports and dashboards. So some of those characteristics. Usually it's very coupled. So you have your storage, which you see here. I have proprietary storage, which is usually in some sort of proprietary format. That the vendor stores your data in, and it would have to be a highly optimized engine on top of that so that you could interpret data in that format. Typically, you get really good performance in the data warehouse, although problem is it can get really expensive. So this is where we see a lot of companies start to have challenges with their data warehouse. Cost or price performance starts getting really high, especially as they're throwing more compute resources at their data. And it's also a really locked in type of system. Data formats, like I've mentioned a few times now, are proprietary. So now to address those things, we're seeing what we call the Open Data Lakehouse gaining a lot of steam. The stack has been separated out. The storage is no longer coupled to the compute. It's scalable. You can leverage the cloud. Let me do my build here. There we go. You can leverage the cloud. It can be elastically scalable, and it's relatively low cost. So the amount you're paying for the storage is very cheap compared to the warehouse. And now that your storage is no longer tied to your compute engine, you can leverage many different types of compute. And by the way, that storage can be anything: text, image, videos, files, in many different formats. So you can read those, that you can use those different engines to read it. So then you have your engines on top. You have your let me do this build, your ML and your AI frameworks. You have Presto, which I'll spend some time talking about. So Presto allows you to access the data in your data lake, like S3, and expose it with a SQL interface so that you can work with that data as if you were working with tables in a data warehouse. So like select star from some table, it'll access the data in the data lake and return the results in a table. And that's how you get your reporting and your dashboarding, et cetera. And then you have your governance, discover quality, security technologies like Apache Hoodie and Iceberg, those table formats that give you even more parity with the data warehouse. And I won't go into a ton of detail on this. You can see that right here. But I want to show kind of the whole picture here and how we're looking at the data warehouse. And let me finish this build. Sorry, it's a little delayed here. Come on. Okay, there we go. And then we finish it out with our governance, discovery, quality, and security. So this is kind of what when we talk about the Open Data Lake Warehouse, this is the architecture we are seeing and what we talk quite a bit about. And like I mentioned earlier, the reason we're seeing this shift to the Open Data Lakehouse is to solve for those two key challenges with the data warehouse: cost and flexibility. Price performance is much better on the Open Data Lakehouse, and you have a lot more flexibility with open formats and open technologies, open source, and the like. So I'm guessing or hoping that many of you joined today to learn more about what you should be thinking about as you're making some architectural decisions around unified analytics or choosing a data warehouse or a data lake. So we've put together some considerations to think about as part of that process. And there are 8 areas to drill into. I won't go really deep into each of these, but I hope they kind of help frame these for you. So starting with data, what kinds of data do you need to support? Can your approach support the breadth of that data? Next. Analytics. So you want to be able to support a broad range of analytics, not just SQL, but Python, notebook, search. You want to plan for the future. So set yourself up with a solution that can support a broad range of analytics. Users. Does your solution support a broad set of users on a single platform? What does your platform support? Cloud is critical. Does it support your enterprise requirements? And is it cost efficient? Drilling down into cloud, is it elastic? Do you need automation? Is it scalable? Is mobility, globality? Can you do it as you expand out to new regions? Drilling into the enterprise, looking at things like security, privacy, governance, unification. How important are these to your use case? And do you need to have these things in place as you make your decision? Looking at business, does it support business semantics and the logic I want to include in that? Will it allow me to create measurable value for my organization and optimize? The goal is obviously to create more value over time. And then cost, will you be able to forecast your cost accurately over time? What's the cost at scale as it grows? And anyone that's doing analytics, will those analytics grow over time? Will you be able to scale as your business grows without having to break the bank? So the way platform teams are evaluating technologies is changing from what we see. Specifically, we're seeing a lot more wanting to start in kind of a pay-as-you-go model, so that you only pay for what you use as you decide what technologies you're going to leverage. And it's usually a consumption-based model. So make sure you have that option because it gives you the flexibility to try those things out. And you don't have to have this an exorbitant cost to do that. The cloud is allowing that and enabling that in a much bigger way. And it's been certainly a bigger trend that we're seeing. So I thought I'd take just a few minutes to talk a little bit more about Ahana. So first, let's just start with Presto. So what is Presto? It's an open source distributed SQL query engine for the data lake and the lake house, which you saw in the data lake house architecture slide. It was built for fast analytic queries against data of any size. The project came out of Facebook back in 2013. Today, it's being used at scale at internet giants like Uber, Twitter, TikTok, in addition to Meta. You can query data in place. You don't need to move or to ETL your data, which is massively powerful. And it supports federated querying, so you can join data from different source formats. So today, Presto is governed by the Linux Foundation. It's an open, neutral, open source project. There's a lot of companies, big and small, today that are leveraging Presto. I won't go into a ton of technical detail here on Presto, but there are a lot of resources available on ahana.io that will take you into more depth into the architecture, et cetera, if you want to go deeper into Presto. But I will go into some of the most popular use cases and how we see customers and users using Presto today. So starting with interactive ad hoc querying, that's right in Presto's sweet spot. You can run interactive queries on your data as you need, and that's all in your data lake. A lot of reporting and dashboarding, traditional data warehouse workloads, but we also see federation across different sources or different data lakes. Some of these applications are powering customer-facing applications. And taking advantage of the more advanced functionality that the Data Lakehouse can provide with Data Lakehouse analytics and transformation using SQL. So what's Ahana? Ahana Cloud for Presto. Our mission in a nutshell is to simplify the use of Presto and make it accessible and usable for data platform teams of all sizes. We're a SaaS for Presto. We've built it to be fully integrated and cloud native. So it kind of gives you the best of both worlds. You have full visibility into your clusters, into your nodes, but you don't have to worry about installing and configuring everything. Given the vast potential of the Open Data Lakehouse and what it provides, there's still a lot of challenges in standing up that kind of environment. So really what we do at Ahana is we want to create the easiest managed service for Presto, and we want to enable you to do that, to do SQL compute on top of your data lake. So those are those reporting and dashboarding use cases, your lakehouse type applications, and supporting data teams of all sizes. So quickly, it's free to get started. It's just pay as you go. It's all in the AWS marketplace, and it's a really great and easy way to get started with Presto for your data lake on your way to the data lakehouse. So let's talk about some real world use cases. First, Blinkit. So Blinkit is India's instant delivery service. Their mantra is everything delivered in 10 minutes. And they are currently using Ahana for Presto. Challenges they faced around their data warehouse architecture was really price performance. And so the data warehouse was doing the job as they got up and running, but as the company grew and they threw more data at it, which meant that they needed more compute resources against that data warehouse data, costs were starting to become completely unruly. And so they wanted to move to a more open approach. They knew they liked Presto, which was the SQL query engine. They wanted to be able to leverage open data formats, open source technologies, while still remaining in the cloud. And so they moved to Ahana for Presto. Today, they have built an open data lakehouse architecture with Presto as the SQL query engine for their open data lakehouse. They're using the Ahana managed service to run Presto. Today, they're powering about 200,000 orders per day. We did a really great session with them. If you're interested in learning more, Satyam from Blinkit shared more about the use case and how Ahana is, providing Blinkit with the SaaS managed service for Presto, giving them the data management capabilities they need to make this instant delivery a true promise. So really great use case. We were excited to see them, and we're looking forward to see all that they do with Presto and the Open Data Lakehouse. Next, Securonics. So Securonics is a security information and event management software. They're a leader in the SIM space. Similar to Blinkit, they also were seeing challenges around price performance. They knew they needed a SQL-based solution for their data lake. They experimented with several different offerings and eventually came to Ahana because Ahana gave them the ease of use for Presto, in addition to still enabling them to use the full power of the Presto query engine at a very large scale. So today they're using Ahana for Presto for their in-application SQL analytics on their S3 data. They call it threat hunting. So they are literally scanning like billions of events per day that get stored in S3 and running reports on those and looking for potential threats for their customers. Big item for them was price performance. Their costs, similar to Blinkit, were starting to skyrocket. The more these events that they were pulling in, the more compute needed to run the analytics on those events. Costs were getting super expensive. And so they moved to Ahana Cloud and they saw about a 3x better price performance on their data and with the use of Presto on their data lake. So two kind of key case studies, Securonics and Blinkit, and why they chose Presto for the Open Data Lakehouse and the data lake, and some of the results they've seen. So with that, that's it. I hope you folks enjoyed it. I hope you gained a little bit of knowledge in the data warehouse, data lake, kind of in your journeys, depending on where you are. Ahana is happy to help guide or answer any questions if you need it. And we are looking forward to seeing more folks leveraging this idea of the Open Data Lakehouse with SQL at its core. Thanks, folks.